Alright, so for 253, this is a proof. Alright, so let's set it up first. Let me just see here. Okay, so we'll set up two columns. One we'll call statements, and the other we'll call reasons. So we're trying to prove that this thing is a parallelogram. And in order to prove a quadrilateral is a parallelogram, all you need to do is show that one pair of opposite sides are congruent. Okay? If you can do that, then you've proven it's a parallelogram. So let's put a little note over here. Show one pair of opposite sides are congruent to prove a quadrilateral is a parallelogram. Okay? So, let's see here. One of the first things that we can say is that FE is congruent to itself, right? So let's say, actually, let's write, let's write FE is congruent to FE. And whenever we say that, we want to put the reflexive property. That's what that's called when you say something is equal to itself. And you'll see why I'm saying that in a second. Okay? Just follow me here. So, for number 2, we could say that AE minus FE is congruent to FC minus EF. So if I take AE, which is this piece right here, and I subtract FE, that will be the same thing as taking CF and subtracting EF from it. Okay? And that's by the line segment subtraction theorem. Okay, let me just see something here. Okay, so for another reason now, or another statement I should say, we can say that AF is congruent to CE. And we can say that by substitution. Okay. Then we can say that angle BFA is congruent to angle DEC, and that's because all right angles are congruent. So let's just mark off on our triangle what we have so far. We know that this is congruent to this, and these are right angles, so we know that those are all the same. So I'll just put boxes here and here. Okay? So let's see. What can I say now? And we know that this angle is congruent to this angle because it's given, but we have to say that also. Hang on one second. I messed up. I'm supposed to put all this information. So let's put number 1 and put ABCD is a quadrilateral. AFEC is a diagonal. AE is congruent to FC. I was supposed to put that first, okay? BF is perpendicular to AC. DE is perpendicular to AC. And angle 1 is congruent to angle 2. Alright? So this is really number 1, and that's because all this information is given. So let's change these numbers. Two, 3, 4, 5. 2, 3, 4, 5. Alright, so and then I'll take one of these things and arrow it up there. Okay? So now remember, one of the ways to prove triangles are congruent is angle, angle, side, right? Angle, angle, side is congruent to angle, angle, side. So then we know that these two triangles over here are congruent. So for number 6, we can say triangle BFA is congruent to triangle DEC. Okay, and the reason for that is angle, angle, side. So now that we know that those triangles are congruent, we know that this side is congruent to this side, and this side is congruent to this side, and this angle is congruent to this angle. And that's because corresponding parts of congruent triangles are congruent. But so what we want to write here is AB is congruent to CD. BF is congruent to DE. And let's say angle BAF is congruent to angle, let's see, BAF DCE. And that's because of corresponding parts of congruent triangles are congruent. Okay, and those are the two sides and the angles that I just labeled. That's what we just did there. So let's keep going. Next, we can say angle BFC, because I don't think I wrote this one yet, is congruent to angle DEA, and that's also because all right angles are congruent. I already labeled that in my diagram, so I just had to put down the reason and the statement. Now I'm going to say that triangle BFC is congruent to triangle DEA. You see BFC, this triangle up here? Well, that's congruent to, what did I say, DEA, this triangle down here. Okay? And the reason we can write that is because sine, angle, side. Right? I usually put an X on the reflexive property piece. So this piece plus this piece is the same as this piece plus this piece. So we know that this side is the same as this side. We also know that this side is the same as this side, and the angle in between the two sides is the same, right here and here. So side angle side is congruent to side angle side. So then we also know 1, 2, 3, 4 that this side is congruent to this side, and that this angle is congruent to this angle, and this angle is congruent to this angle. Okay? So we don't need all of that. Okay? What we do need to say is that AD is congruent to CB, and that's because of what we just said with the CPCTC, because we just proved those triangles were congruent. Now we can say ABCD is a parallelogram, and the reason would be opposite sides of a quadrilateral are congruent. So ABCD is a parallelogram. Okay? There was probably maybe a little easier way to do this one, but this it's supposed to say two. Show two pairs of opposite sides are congruent to prove a quadrilateral is a parallelogram. So that's why I wanted to show that two pairs of opposite sides were congruent. Okay? That's what you have to do to prove a parallelogram. There might have been a shorter way, but because that's the longest proof I've ever seen, to be honest with you. Alright, but we're going to move on. (254). Another proof. Okay? Let's see. Statements, reasons. So, what are we given? That JKLM is a parallelogram, and that JM is congruent to LN, and angle LMN is congruent to angle LNM. Alright, and that's because it's given. So let's just label our diagram. JM is congruent to LN, and LMN is congruent to LNM. So we have that so far. Okay? So, and we're trying to prove it's a rhombus. Alright? So, for my first real statement, I think what I'm going to say is JK is congruent to LM. And that's because opposite sides of a parallelogram are congruent. So now I can say JK is congruent to LM. And let's see, LM is congruent to LN, And that's because of the isosceles triangle theorem. Because this is an isosceles triangle if its base angles are congruent. So since these two sides are congruent, I'm going to add one to this, and since these two sides are congruent, I'm going to add one to this. So I know that all four of those sides are congruent now. Now, we should probably put as number 3, this should really be number 4. And we should put triangle LMN is isosceles, and that's because base angles let's say because an isosceles triangle has two congruent angles. And let's do a little switcheroo there, okay? So now we're almost done. We could say LM hold on. LM is congruent to JM, and that's because of the transitive property. All right. See, what I knew from the beginning was that JM and LN were congruent, right? But then I said that these two are congruent. Well, if this is congruent to this one, and these two are congruent, then that means this must be congruent to this one. And that is called the transitive property. Okay? When one thing is congruent to something and another thing is congruent to that same something, then those two things are obviously congruent. But you have to write that down, and you have to write down the transitive property. That's what that's called. Now, let's see. For number 6, hang on one second. JK LM. What about KL and JM? Did I say anything about those yet? No. I need to say now that JM is congruent to KL because opposite sides of a parallelogram are congruent. Finally, since now we know all four sides of this shape right here are congruent, we know that it must be a rhombus then. So the final statement is always our proof statement. JKLM is a rhombus. And that's because all four sides are congruent. That's it. Okay? Let's see. Sometimes there's other ways to do these too, but this is just the way that I'm seeing. The coordinates of the vertices of parallelogram ABCD are those, the slopes of which line segments could be calculated to show that ABCD is a rectangle. Okay. Let's quickly draw this picture. -3, 2, -2, -1, 4, 1, and 3, 4. So this is A, B, C, D. The slopes of which line segments could be calculated to show that ABC is a rectangle? AB and DC, no, right? It has to be a right angle. It has to be, rectangles have right angles, so it has to be one of the two lines that are next to each other. AB and BC, AB and BC, it would be that one. And if you look at the next choice, AD and BC, AD and BC, no, those are parallel. AC and BD, AC and BD, those are diagonals. So it's choice 2. That's problem 255. (256). Let's see. I can do the midpoint of either one of these. So I'm going to choose A and C because those are the diagonals. I have to do the midpoint of the diagonals. So x1 plus x2 over 2, comma y1 plus y2 over 2, right? That would give me 1 plus 3 over 2, comma 5 plus -1 over 2. 4 over 2, 4 over 2, 2 comma 2. Okay. Let's look at 257. Okay. -5, 6. Six, 6. 8, -3. And -3, -3. Okay. So what we have here, well, let's see what the question says first. Okay. So we have a quadrilateral with these vertices. We want to prove it's a parallelogram, but is neither a rhombus nor a rectangle. Okay. So first let's show that opposite sides are congruent to prove that it's a parallelogram. Okay. So AB is congruent to DC, and that's because AB equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and DC equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? And now we can say alright, I have to use the distance formula to figure out the length of AD and BC. Alright, so let's say AD is congruent to BC, and now let's show why. So it's x2 minus x1 squared plus y2 minus y1 squared. So I have x1, y1, and d will be my x2, y2. So negative 3 minus negative 5 squared plus negative 3 minus 6 squared. So I have the square root of 2 squared plus negative 9 squared, which is the square root of 4 plus 81. So AD is the square root of 85. Okay? And we don't have to simplify that. Let's go right to BC now, which we have the same formula, right? x2 minus x1 squared plus y2 minus y1 squared. This time B is x1, y1, and C is x2, y2, right? So I have eight minus 6 squared plus negative 3 minus 6 squared. 2 squared plus negative 9 squared. 4 plus 81. So there, BC equals the square root of 85. Okay? So I just showed that AD and BC have the same length, so then therefore they're congruent. Okay? Now, to prove that it's not a rhombus, well, we've already done that, okay? Because we know that the side lengths are different, all right? Because in a rhombus, all the sides have to be the same. So 11 is not the same thing as the square root of 85. Now, to prove that it's not a rectangle, we have to show that the slope, we have to show that there's not four right angles, okay? So the slope of AB equals 0, and the slope of AD equals it's negative 9 over 2. Okay. And those are obviously not negative reciprocals. So let's write this out in one big statement. We're going to write since AB is congruent to DC, which we showed why, and AD is congruent to BC, which we showed why also, ABCD is a parallelogram because opposite sides are congruent. Now, since AB is not congruent, so I picked AB and I could have to pick one of the other sides, either AD or BC. Since it's not congruent to, let's say, AD, ABCD is not a rhombus. And since the slope of AB and the slope of AD are not negative reciprocals, ABCD is not a rectangle. Alright, because if the slopes were negative reciprocals, then the lines would be perpendicular, which means they would be 90-degree angles. But since that's not the case, there are no 90-degree angles, and therefore it's not a rectangle. Okay? So let's go on to 258. Alright. Quadrilateral MATH. Alright, so we got another one of these. Alright, so we have 1, 1, negative 2, 5, 3, 5, and 6, 1. So this thing's a quadrilateral, and to prove that it's a rhombus, first of all, we have to show that all four sides are congruent. And then to prove that it's not a square, we have to show that there are no right angles. Okay? Or all we have to show really is that all four sides are congruent, because that proves it's a rhombus, and then we just have to show that any two sides that are next to each other are not perpendicular. Okay, which means they don't form right angles, so then they're not it's not a square. Okay? So up here, let's start off by saying AT equals 1, 2, 3, 4, 5. And MH equals 1, 2, 3, 4, 5. And AM equals, well, now I'm going to do this a little differently. I'm going to say AM squared, right, because that's the diagonal of a right triangle here, right? So AM squared is equal to 1, 2, 3, 4 is equal to 4 squared plus 1, 2, 3 squared. So am squared equals 16 plus 9. Am squared equals 25. So am equals 5. So here's one piece of info, here's another piece, here's another piece. And then I'm also going to show right next to this, because there's a triangle right here too, right? A right triangle here. So we can solve for th in the same way. Th squared equals, again, 4 squared plus 3 squared. So th squared equals 16 plus 9. Th squared equals 25. Th equals 5. Okay? So, since all 4 sides are congruent, in parentheses I'm going to put the same length, quadrilateral MATH is a rhombus. Alright, but now we have to prove that it's not a square. So the slope of AT is 0 and the slope of AM is 1, 2, 3, 4, negative 4, 1, 2, 3, so negative 4 thirds. So since the slope of AT and the slope of AM are not negative reciprocals, then AT is not perpendicular to AM, and therefore MATH is not a square because all 4 angles are not right angles. Okay? These problems are pretty long. Let's see what's next. Oh, geez, one more. All right. Negative 6, negative 2. Two, 8. Six, negative 2. All right. AB has midpoint D. All right. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 over and 10 up. Instead, I'll go 4 over and 5 up to find the midpoint. 1, 2, 3, 4, 1, 2, 3, 4, 5. That's D. BC has midpoint E, so I have to go over 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead I'll go over 2 and down 5. And AC has midpoint F. Well, let's see. That would be right in the middle here. Okay. Prove that. Let's connect these. Well, we want to prove ADEF is a parallelogram. Okay? And you can see ADEF right here. So, let's just prove that. Oh, and it says prove it's not a rhombus. So let's just, so we know DE is 1, 2, 3, 4, 5, 6. We know that AF is 1, 2, 3, 4, 5, 6. So that means that DE is congruent to AF. Now, AD squared, right? Now here's my triangle thing again. I like to do the triangle. I think it's easier than the distance formula. That's just my opinion, so that's what I'm going to use. 1, 2, 3, 4, 5, 1, 2, 3, 4. So it's equal to 5 squared plus 4 squared, which is equal to 25 plus 16. So AD squared is equal to 41. So AD is the square root of 41. Now, EF, I'm going to do my triangle thing with EF also. EF squared is equal to 1, 2, 3, 4 squared plus 5 squared again. EF squared equals 16 plus 25. EF squared equals 41. EF equals the square root of 41. So, AD is congruent to EF. Okay? So since DE is congruent to AF and AD is congruent to EF, ADEF is a parallelogram because opposite sides are congruent. And it's easy to prove it's not a rhombus, but because since, just choose one of those, so since DE is not congruent to AD, ADEF is not a rhombus because all four sides are not congruent. Okay? That's all you have to do for that one. Okay. 260. In diagram below, circle O has a radius of 5. So we know this is 5 and this is 90 degrees. And if this is 2, this must be 3. And then that means that this is a right triangle and it's got to be a 3, 4, 5. So these are both 4. So what is the length of BD? 8. Okay. In the diagram below, ABC is inscribed. Oh, the triangle's inscribed in the circle. The distances are shown. Which statement about the sides of the triangle is true? Well, I know that since CB is farthest away from the center, it has to be the shortest. And then AC would be next, and AB is the longest. So AB is greater than AC, which is greater than BC. It's this one. And it even looks like it in the picture. OC is 5. It's a radius, so I also know that this is 5, and I know that this is 5, and this is a right angle. What is OP? Oh, chord. AB is 8, so I know this is 4, and this is 4, so then this must be 3 for the 3, 4, 5 triangle, and that's what they want, OP. Okay. OA is 6, so that means that this is 6, and this is 6. OE is 2, so I know this is 4. CE. Okay, so this is X, and I know this is a right angle. So here's a right triangle. 2 squared plus X squared equals 6 squared. 4 plus X squared equals 36. Subtract 4. X squared equals 32. So X is the square root of 32. Take 32, break it down. You can do 2 and 16, 2 and 8, 2 and 4, 2 and 2. So X is the square root of 2 times 2 times 2 times 2 times 2. Bring 1 out for those two, and bring 1, 2 out for those two. So, and multiply those together, so we have X equals 4 radical 2. Choice 4. Let's just double check. That's what they're asking us for. CE. Yep. Okay, let's see. DB is 34. So we know that this OD has to be half of that. So 15, 17. And we know that this also, I'm not sure if they're going to ask us for this, but we know that these two lines would be 17. These are right triangles. Because it says they're perpendicular. AC is 30, so this has to be 15, and this has to be 15. Okay? So they're asking us for BE. Well, first I could find OE, and then I'll be able to find BE. So x squared plus 15 squared equals 17 squared. This is one of those Pythagorean triples also. But let me just get my calculator out. A lot of people don't remember this one, so I just want to do it. We have x squared plus 225 equals 289. Subtract 225. Get x squared is 64, so x is 8. So this is 8, that means 17 minus 8 is 9, so this must be 9. So BE is 9. Okay, let's see. It's perpendicular, so we know that there are 4 right angles here. AO is 10, so we also know this is 10. And we know this is 10. BE is 4, so we know this is 6. Find the length of CE, so that's just x. Well, that's a 3, 4. It's a 3, 4, 5 triangle, doubled, right? So x. Well, I guess we should show the work because it's not a multiple choice. X squared plus 6 squared equals 10 squared. X squared plus 36 equals 100. Subtract 36. X squared is 64. X is 8. So CE is 8. Because CE is X. Okay. Alright, let's see. AD is 60. And it says that CD is parallel to AB. Well, parallel chords intersect parallel arcs. I mean congruent arcs. So if that's 60, then we know this is 60. And also inscribed angles are 1/2 the measure. These are inscribed angles. Okay, they're 1/2 the measure of the arcs, so they're 30. And that's what it's asking for. It's asking for CDB, this one. These are parallel, so that means that if AC is 30, we know this is 30. And this has got to be 180. It's a half a circle. So 180 minus 30 minus 30 is 120. So that's the answer because it's asking for CD. AB is parallel to CD, is parallel to EF. Which statement must be true? CE is congruent to DF? Yeah, that's true. Arc CE must be congruent to arc DF. Okay, we have parallel chords. AC must be congruent to BD, so it's choice 1. Parallel chords intercept congruent arcs. That's the rule. AB is parallel to GH. Chord CD intersects AB. Alright, which statement must always be true? AG must be congruent to BH. So this chord here intersecting just tried to confuse you. You didn't even need it. Okay, these are congruent. Arc CD is 70. What is arc AC? Well, x plus 70 equals 180. 2x plus 70 is 180. Subtract 70. 2x equals 110. Divide by 2. X is 55 degrees. It's choice 3. Okay? And you guys know that this other arc would be 180, right? Because it's a semicircle. Semicircles are 180. Full circles are 360. Okay, let's see. A trapezoid, we know that these lines are parallel. It has one pair of parallel sides. With diameter, if AB is 80, find BC. Well, again, this is the same deal. Right, that's 180. So we know x plus 80 equals 180. 2x plus 80 equals 180. Subtract 80. 2x equals 100. Divide by 2. X is 50 degrees. So arc BC, the measure of arc BC is 50 degrees. Two parallel lines. Alright, so we know that the arcs are equal. 2x minus 20 equals x plus 20. Plus 20 plus 20. 2x equals x plus 40. Subtract x. x equals 40. So the measure of arc AB is x plus 20, which equals 40 plus 20, which equals 60 degrees. Okay. In the diagram below, we have these two. With total number of lines of tangency, well, these guys have 1, 2, 3, 4. There they are. Okay, 275. These guys have 1, 2, 3. 3 lines of tangency when the circles are touching. Line segment AB is tangent to circle O at A. So we have a circle O, A, B. When you connect A, B, and O, you always have a right triangle because the tangent is always perpendicular to the radius. Okay? So you always have a right triangle. Here you go, 90 degrees. Always, it's a rule. We have this external point. We have 2 tangents drawn to some circle. Circle O. And the radii are drawn OA and OB. If APB is 40, what is the measure of angle AOB? AOB. Now, I know one way to do it, but I'm trying to see if there's a faster way. No, I guess not. All right, we can split this into two right triangles. Okay, each one of these angles would be 20, and then so we know each one of these angles would be 70. So we know the total one would be 140. Okay. Alright, we know that this is a right angle. OB is 7, BP is 18. What is the length of AP? Well, if this is 7, this is 7, right? So we have here 7 squared plus 7 plus 18 squared equals x squared. 7 squared plus 25 squared equals x squared. This is a Pythagorean triple, but I'm going to show you to work. Did I add this right? 25 squared. 674. No, I think I did something wrong here. 7 squared. I did do something wrong. 7 squared plus x squared. Right? Equals 7 plus 18 squared. 49 plus x squared equals 25 squared. 49 plus x squared equals 625. Subtract 49. X squared is 576, so x equals 24. It's choice 4. Let's just double check. What do they want to know? AP, that is x, 24. Alright. TA to AC is 1 to 3. TS is 24. This is 1x and this is 3x. So 1x plus 3x equals 24. 4x equals 24. X equals 6. SE equals 3x equals 3 times 6 equals 18. Okay, oops, let me sharpen my pencil here. The diagram below of circle O, chords AD and BC intersect at E. Arc AC is 87, BD is 35. What is the degree measure of CEA? So angle CEA is equal to 1/2 87 plus 35. This is one of the rules. 1/2 of, let's see, 110, 122. So that's 61 degrees. Choice 2. These angles are equal to 1/2 the sum of the arcs. Let's see. What do they want? Angle ABC. It's the same thing. Angle ABC equals 1/2 of 36 plus 20. So that's 1/2 of 56. So 28 degrees. Choice 3. Okay, so if you look at this angle here, ACB, it intercepts this arc, right? Well, so does ADB, and that's this right here. Then if you look at this angle right here, CAD, it intercepts this arc. Well, so does DBC, so we know that those have to be congruent. Okay, because if inscribed angles intercept the same arc, they're congruent. And now look, we have vertical angles, so 1, 2, 3, 1, 2, 3. So we know if 3 angles of one triangle are congruent to 3 angles of another triangle, then we know that those 2 triangles are similar. Let me just see something. Okay. QT is 140. Angle P is 40. RS. Okay, this is another rule. 40 equals 1/2 of 140 minus x. It's the difference now. So 40 equals 70 minus x over 2. So let's subtract 70. Negative 30 equals negative x over 2 times by negative 2. So x equals 60. It's choice 2. Let's see, opposite angles J and M. They must be supplementary, right? if you ever have a quadrilateral inscribed in a circle, the opposite angles are always supplementary. Okay? And you can do that by thinking about inscribed angles. Okay? Let's see. We want to know this. So it's a little different. This time 34 equals 1/2 of 50 plus x. 34 equals 25 plus x over 2. So we subtract 25 from both sides. We get 9 equals x over 2. We times 2 on both sides. Excuse me. We get x equals 18. 287. ln 3, so ln is 3x, nk is 4x, and kl is 5x. So we know that 3x plus 4x plus 5x equals 360. So 5, 6, 7, 8, 9, 10, 11, so 12x equals 360. Divide both sides by 12. So x is 30. We know that angle LMK is equal to 1/2 of, so 5x would be 150, 4x is 120, and 3x is 90. Let me just double check that. 270 and 90. 360. Good. So it's 1/2 of 150 minus 90. So it's 1/2 of 60. So it's 30 degrees. Okay. Let's see, DF is 5x, FE is 2x, EG is 1x, and GD is 7x. So 5x plus 2x plus 1x plus 7x. 7, 8, 9, 10, so we have is equal to 360. So 15x equals 360. Divide by 15. We get x equals, let's just see real quick, 24. I don't even think we needed that. Oh yeah, we did. So 2x is 48. 1x is 24. 5x 24 times 5 is 120, and 7 times 24, so 7x is 168. Alright, so let's see. And give their measure. So angle EGF is congruent to angle EDF, and the measure of angle EGF equals the measure of angle EDF, which equals, it's 1/2 of 48, which is 24. Whoop. Because of their inscribed angles, they're equal to 1/2 of the arc that they intercept. Let's see. DA is 56. Arc DA. DB is 112. And AC to CB is 3x to 1x. So 1x plus 3x plus 56 plus 112 equals 360. Is that right? Yeah. So 4x plus 168 equals 360. Subtract 168 from both sides. And we get 4x is 192. Divide by 4. 4d8. Let me just double check that. Okay. So 3x is 144. 1x is just 48. Okay. Now what do they want? They say determine the measure of angle CEB. Where is that? CEB. Okay. It's 1/2 of 48 plus 56. So that's 1/2 of, let's see, 104. So that's equal to 52 degrees. That's one of the questions. We also need to find the measure of angle F, which is 1/2 of 144 minus, oh no, 1/2 of, it's 1/2 of 144 plus 48, right? It's this whole angle here, minus 112, which is 1/2 of 144 plus 48 minus 112. That's 1/2 of 80, so it's 40 degrees. And then the measure of angle DAC, where's that? DAC, that's 1/2 of 112 plus 48. 1/2 of 160. 80 degrees. Okay? Let's see. PS is x, PQ is 3, and PR is x plus 18. What is the length of PS? Well, x squared equals 3 times x plus 18. X squared equals 3x plus 320s would be 60 minus 6, so 54. So subtract 3x and subtract 54 from both sides. X squared minus 3x minus 54 equals 0. It'd be 9 times 6. That would be negative. That would be positive. PS is 9. Okay. Okay. X. So h squared equals 4 times 4 plus x. 64 equals 16 plus 4x. 4x is 54, 44, plus 4 is 48. minus 3. DE is 2x plus 8, EC is 3, AE is 4x minus 3, EB is 4. Well, 3 times 2x plus 8 equals 4 times 4x minus 3. 6x plus 24 equals 16x minus 12. So I'm going to subtract 6x from both sides, and I'm going to add 12, and I get 36 equals 10x. So divide by 10, x is 3.6. And that's what they want, x. Sharpen my pencil. PB is 4. BC is 5. What is PA? So x squared equals 4 times 4 plus 5. X squared equals 4 times 9. X squared equals 36. So x equals 6. What do they want to know? That's what they want to know. Let's see. AE is 4, AB is 12, and DB is 6. So that means this is 6. What is OC? Well, 6 times 12 equals 4 times 4 plus x. So 72 equals 16 plus 4x. Subtract 16. 4x equals 62, 52, 56. Divide by 4. X is equal to 14. So OC is 14 over 2 is 7. Careful with that one. CE is 10. ED is 6. AE is 4. What is EB? Well, 4x equals 60. X equals 15. And then a piece of cake. So we know this is congruent to this, we know this is congruent to this, and we know this is congruent to this. AF is 6, CD is 5, and BE is 4. So then we know a lot of other stuff too. What is the perimeter of triangle ABC? 6 plus 4 plus 4 plus 5 plus 5 plus 6 is, well, that's 10, and that's 10, and that's 10 is 30. Let's see. What is the length of BC? Let's call it x. 8 squared equals 4 times 4 plus x. I believe we already had this exact same problem. Maybe it was slightly different, but I don't think so. 4x equals 54, 44 plus 4 is 48. Divide by 4. X equals 12. So this is congruent to this, because all tangents from the same external point are congruent. That's how I know this. AB is 20. AE is 12, so this is 8, so this is 8, so this is 12. CF is 15, so this is 15. What is the length of AC? 12 plus 15, 27. AE is 8, BE is 9. Find the length of CE in simplest radical form, and it says that it bisects, right? So each one of these is x. So x squared equals 72. So x is the square root of 72. So if I break down 72, I got 2 and 36, 2 and 18, 2 and 9, 3 and 3. So x equals the square root 2 times 2 times 2 times 3 times 3. So x equals 6 radical 2. And the last one for today. In the diagram below, we got a bunch of stuff going on. The length of RM is QM is 2. SM is 12. PT is 8. And it says RM is 2 more than the length of TM. So if TM is X, RM is X plus 2. Find the length of RT. Well, I know that X times X plus 2 equals 24, because it equals 2 times 12. So x squared plus 2x equals 24. Subtract 24 from both sides. X squared plus 2x minus 24 equals 0. So we're going to have an x and a 6, and an x and a 4, and a plus and a minus. So x plus 6 equals 0, x minus 4 equals 0, plus 4, minus 6, minus 6. So we can reject. So RT equals x plus 2 plus x, which is 2x plus 2, which is 2 times 4 plus 2, which is 8 plus 2, which is 10. That's my first answer. Then they want PS. So let's call that y. So y squared is equal to 8 times this whole thing, which is 18. Right? Because this piece is 6, and this piece is 4. Okay, so y squared is, let's see, 8 times 8 is 64, 8 times 8, 9, so 144. So y is 12. So PS is 12. Okay? And let me just see something real quick on that one. Let's see. Okay, so that is it for tonight.